Space isn't just beautiful, it's deadly. Beyond our solar system lie planets with extreme heat, crushing gravity, violent storms, and bizarre landscapes that make Earth look tame. In this journey, we'll explore the top 20 most terrifying planets in the universe, worlds that defy imagination and confront us with the raw power of nature. Wasp 76b, the Iron Rain world. Wasp 76b is a world that turns the idea of a storm into a nightmare for the imagination. Situated about 640 light-years away in the constellation Pisces, this planet is classified as a hot Jupiter, a gas giant similar in size to Jupiter, but orbiting extraordinarily close to its star. Its proximity results in extreme tidal locking, meaning one side of the planet always faces its blazing star, basking in continuous daylight, while the other side remains in eternal darkness. This constant exposure to stellar radiation drives temperatures on the day side to over 2,400 degrees Celsius, hot enough to vaporize metals like iron, magnesium, and titanium almost instantly. The true terror of WASP 76b lies in its atmospheric dynamics. The fierce heat on the day side causes metals to evaporate and mix with other gases, creating an atmosphere dense with iron vapor. Then, powerful winds, reaching thousands of kilometers per hour, transport these vaporized metals to the night side, which is much cooler by comparison. Here, the metals condense and precipitate as actual iron rain, falling from a sky blackened by perpetual night. This is not a gentle drizzle. It is heavy, molten metal rain, potentially lethal to anything that could hypothetically survive the initial heat of the day side. The concept of rain on WASP 76b challenges everything we know about precipitation. On Earth, rain forms from water vapor condensing into droplets. On WASP 76b, entire metals are heated to gas, transported across the planet by ferocious winds, and then fall as liquid iron, turning the night side into a torrential, metallic downpour. Adding to its nightmare-like conditions, the atmospheric circulation is driven by extreme temperature differences between the day and night sides. The day side receives unrelenting radiation from its host star, while the night side loses heat rapidly into space. This creates supersonic winds that whip around the planet, carrying clouds of vaporized metal across thousands of kilometers. Scientists estimate wind speeds on WASP 76b could exceed 7,000 kilometers per hour, fast enough to strip the atmosphere and batter the surface with shards of condensed metals. Any hypothetical observer attempting to traverse this planet would face not only lethal temperatures, but a brutal combination of hurricane-force winds and deadly metallic rain. Observations of WASP 76b were made possible using sophisticated instruments like the Very Large Telescope in Chile, which detected the spectral fingerprints of iron in the planet's atmosphere. These findings marked a groundbreaking discovery in exoplanetary science, the first time heavy metals were observed condensing and falling in precipitation on another world. This revelation reshapes our understanding of what extreme planets can be. On Earth, metals abound in rocks or ores, but on WASP 76b, the natural processes of the atmosphere and stellar radiation convert these metals into weather phenomena that are literally falling from the sky. The planet's extreme day-night temperature contrast, estimated to exceed 2,000 degrees Celsius, also drives chemical reactions that would be impossible on Earth. On the day side, the vaporized metals exist in a superheated gaseous state, while on the night side, they condense rapidly, creating a continuous cycle of evaporation, transport, and precipitation. This ongoing process means that the night side is in a constant state of bombardment, with iron rain potentially forming rivers of molten metal across a landscape hidden in eternal darkness. Scientists even speculate that other metals, like magnesium and aluminum, could also rain down, adding layers of chemical complexity to this terrifying phenomenon. But WASP-76b's horror is not limited to temperature and metal rain. Its atmosphere is full of high-speed ionized particles, energized by intense radiation from the host star. This makes the planet's sky electrically charged, meaning storms could also produce deadly lightning strikes in addition to iron rain. Imagine a world where each night is a brutal storm of molten metal, whirling winds, and searing lightning, conditions that dwarf any storm ever experienced on Earth. While humans cannot survive these extremes, studying WASP-76b helps scientists understand atmospheric physics in high-energy environments and the limits of planetary formation under extreme stellar irradiation. From a broader cosmic perspective, WASP-76b exemplifies the diversity and danger of exoplanets. While it is visually unobservable in the sense of human-scale perception, its existence challenges our understanding of what weather can mean. Water-based precipitation and mild winds are normal on Earth, but on WASP-76b, the same physical principles operate at extreme scales, creating a world where metals can literally fall like rain, and supersonic winds can transport heat and elements across the globe. This transforms the very concept of a planet from a stable, solid object into a dynamic, violent, and deadly environment. In terms of potential for life, WASP-76b is entirely inhospitable. No organism as we know it could withstand the combination of scorching heat, high-speed metallic precipitation, and toxic atmospheric conditions. It is a reminder that not all planets are created equal. While some may harbor oceans or temperate climates, others exist purely as testaments to nature's capacity for extreme environments. For astronomers, planets like WASP-76b are invaluable laboratories, revealing the complex interplay between stellar radiation, atmospheric chemistry, and planetary physics under conditions far beyond earthly experience. Kepler 70b, the scorched remnant. Kepler 70b is a planet that defies the very concept of survival in the cosmos. Located roughly 3,400 light-years from Earth, this world is one of the few known planets to have endured an almost unimaginable ordeal. It survived being partially engulfed by its host star. The star, a subdwarf B-type, expanded into a red giant at one point in its life cycle, threatening to consume any close orbiting planets. Remarkably, Kepler 70b endured the intense heat, tidal forces, and gravitational stress of this phase, emerging as a charred and terrifying remnant of its former self. The planet's very existence is a testament to resilience in one of the universe's most hostile crucibles. The surface temperature of Kepler 70b is truly astronomical, estimated at a staggering 7,000 degrees Celsius. To put this into perspective, this is hotter than the surface of many stars and enough to instantly vaporize most metals. Any solid matter that might exist on the planet's surface is continually in flux, sublimating into vapor under extreme heat and then interacting with the surrounding atmosphere. Unlike Earth, where temperatures fluctuate moderately with day and night cycles, Kepler 70b is locked in a hellish environment where extreme radiation from its dying star bombards its surface relentlessly. Even if metals could somehow condense momentarily, they would instantly evaporate again, creating an atmosphere thick with metallic vapors. Orbiting extremely close to its host star, Kepler 70b completes a full revolution in just a few hours. Its proximity subjects it to intense tidal forces, which have distorted its shape and may have caused its surface to stretch and compress in violent cycles. These tidal effects not only influence the planet's structure, but also generate immense internal heat, adding to the already staggering temperatures on the surface. Scientists studying Kepler 70b have observed that this combination of extreme heat and tidal stress could render the planet's surface molten for millions of years, with any residual rock or metallic crust existing only as a fleeting layer before being vaporized. Kepler 70b's survival story provides rare insight into planetary evolution under extreme stellar conditions. Most planets that orbit too close to their stars are either consumed during the red giant phase or completely evaporated by intense radiation. Yet Kepler 70b persists, suggesting a robust core and a high density that allowed it to resist complete disintegration. Its endurance reveals a universe where planetary systems are not static, but are shaped dramatically by the life cycles of stars. In a sense, Kepler 70b is a living record of stellar evolution, frozen, or rather molten, in extreme conditions that push the boundaries of our understanding of planetary physics. The environment on Kepler 70b is not only hot, but chemically hostile. With metals constantly vaporizing and interacting in its atmosphere, chemical reactions occur at temperatures impossible to achieve on Earth. This metallic soup could include elements like iron, nickel, and magnesium in vapor form, circulating under high-speed winds generated by the planet's extreme proximity to its star. The night side, if it exists in a meaningful temperature contrast, would still be impossibly hot by terrestrial standards, ensuring that the entire planet remains a blistering, uninhabitable furnace. Kepler 70b also provides a glimpse into the potential fates of planets in other systems. Its existence hints that planetary remnants, forged in extreme environments and surviving stellar upheavals, might be more common than previously thought. Studying such worlds helps astronomers understand how close orbiting planets interact with stars during the red giant phase, and what happens to planetary material when it is partially engulfed. It also challenges assumptions about planetary survivability, revealing that under the right conditions, planets can endure even when stars threaten to obliterate them entirely. Observationally, Kepler 70b was detected using the transit method, noting tiny dips in its star's brightness as it passed in front. Its small size relative to its extreme environment makes it an extraordinary target for study, providing one of the best examples of a planetary core that has withstood catastrophic stellar forces. The discovery of Kepler 70b underscores the importance of high-precision telescopes and photometric studies, which allow us to identify and characterize planets that might otherwise seem impossible to exist. Each data point gathered from this scorched world adds to our understanding of planetary resilience, formation, and the variety of extreme conditions that shape the universe. For any hypothetical visitor, Kepler 70b is utterly lethal. Temperatures surpassing 7,000 degrees Celsius would instantly vaporize any conventional spacecraft, let alone a human being. Even the thickest metal or heat-resistant shield would be consumed in minutes. The relentless tidal stresses, high-speed winds, and dense metallic atmosphere mean that no life could survive, and even unmanned probes would need to be incredibly advanced to withstand more than a fleeting encounter. This is not a world of possibility. It is a universe's warning of the extremes that exist beyond our solar system, a planet forged in fire and radiation, surviving against all odds, yet utterly hostile to any form of life we know. HD 189733b, the Glass Blade Planet. This planet presents one of the most violent and visually terrifying weather systems ever discovered. Orbiting a star roughly 64 light-years from Earth, this world is a gas giant with extreme conditions that make even the hottest hurricanes on Earth seem gentle. Its most infamous feature is its winds, which can reach speeds up to 8,700 kilometers per hour, more than 7 times the speed of sound in Earth's atmosphere. These supersonic winds carry particles that condense into glass-like shards, creating a sky filled with razor-sharp projectiles moving at lethal velocities. In essence, a storm here is not just turbulent. It is a deadly hail of molten silica that can shred through solid matter almost instantly. The glass shards form from silicate particles in the upper atmosphere that condense due to temperature gradients between the day and night sides. The planet is tidally locked, meaning one hemisphere is perpetually exposed to its star, while the other remains in constant darkness. On the day side, temperatures soar to around 1,000 degrees Celsius, while the night side is slightly cooler, but still scorching compared to Earth standards. This extreme temperature difference drives violent atmospheric circulation, propelling glass particles across the globe at speeds that make any surface virtually unrecognizable by earthly standards. If a spacecraft or probe were to pass through these skies, it would face both the challenge of violent winds and a barrage of metallic glass particles, a combination that could destroy equipment in seconds. Adding to the danger, the atmosphere is composed mainly of hydrogen and helium, but with heavy elements like silicates, which contribute to the formation of the deadly glass rain. The planet's proximity to its star exacerbates the violence of its weather. Stellar radiation heats the atmosphere unevenly, creating convection currents that generate supersonic storms. These storms are not localized, but can cover large regions of the planet, creating a near-constant tempest in which the combination of wind and glass becomes a planetary scale weapon. Scientists have calculated that a single storm could easily obliterate any fragile structure, or, hypothetically, any life form that might somehow exist in this infernal environment. Observationally, this planet gained fame due to its deep blue color, which resembles Earth's oceans when seen from a distance. This color results from Rayleigh scattering in its dense, hazy atmosphere, similar to why our sky appears blue, but it belies the deadly nature of the world beneath. The serene appearance is a deceptive camouflage, hiding one of the universe's most violent weather systems. The contrast between its calming hue and the lethal storms raging across its surface serves as a chilling reminder that appearances in space can be misleading. Beyond wind and glass, the planet's atmosphere is a laboratory of extreme chemistry. At these high temperatures, metals can vaporize and recombine, forming transient clouds of molten compounds that feed into the glass particle formation. These chemical reactions, combined with supersonic winds, make the weather highly dynamic and unpredictable. Even without considering surface conditions, the atmosphere alone is an arena of chaos where extreme physics dominate. This makes the planet an ideal subject for studying the limits of atmospheric behavior under conditions vastly different from Earth. From a human perspective, this world is utterly inhospitable. Temperatures alone would destroy any conventional materials, and the high-speed glass rain and supersonic winds would shred anything that approached. The planet provides a grim illustration of how violent and deadly planetary weather can become under conditions of extreme heat and radiation. While scientists study such planets primarily for the insight they provide into atmospheric dynamics and planetary formation, the visceral danger they represent is undeniable. It is a place where the very air is a weapon, and storms are capable of global-scale destruction in moments. This planet also emphasizes the diversity of exoplanetary environments. Not all terrifying planets rely on heat alone. Some, like this one, combine extreme wind, chemical hazards, and unusual precipitation to create conditions that are as lethal as they are fascinating. Its violent atmosphere challenges our understanding of what a planet can be, demonstrating that inhospitable is an understatement when applied to worlds beyond our solar system. By studying such extremes, astronomers can better predict atmospheric behavior on other exoplanets, understand the effects of stellar radiation, and even explore how similar mechanisms might have influenced early planetary evolution in our own system. In summary, this planet is a nightmare in the sky. With winds faster than supersonic jets on Earth and shards of glass raining down across its entire hemisphere, the surface is a deadly gauntlet. Its tidally locked nature, extreme temperature contrasts, and chemically active atmosphere combine to create one of the most hostile environments known. It is a world where storms are literally cutting instruments, and the notion of weather becomes a matter of survival rather than mere inconvenience. This planet teaches us that space can be beautiful, deceptively serene, and brutally violent all at once. TARES 2b, the pitch black nightmare. This planet is one of the darkest worlds ever discovered, a place where light itself seems to vanish. Located about 750 light-years from Earth, it orbits a star similar to our Sun, yet it reflects less than 1% of the light that strikes it. To put that in perspective, this planet is darker than coal, darker than black paint, and even darker than the surface of the Moon. It is so devoid of reflection that it is practically invisible, blending into the blackness of space like a cosmic phantom. The only reason astronomers can detect it is through the tiny dimming it causes as it passes in front of its star, revealing its eerie presence. The darkness of this world is not a simple absence of light. It is the result of its unusual atmospheric chemistry. Unlike Earth, where clouds and surfaces scatter sunlight back into space, this planet's atmosphere contains compounds such as vaporized sodium, potassium, and titanium oxide, all of which absorb light efficiently. Instead of bouncing photons away, it devours them, trapping the energy and radiating it outward as heat. This makes the planet incredibly hot, with surface and atmospheric temperatures exceeding 1000 degrees Celsius. Rather than being illuminated, the planet becomes a cosmic furnace, glowing faintly with thermal radiation that is only detectable in infrared. The mystery of its blackness goes deeper. Astronomers initially expected such a planet to have reflective clouds or bright features, especially because it is a gas giant orbiting very close to its star. Yet observations reveal no such features. The atmosphere seems to resist forming reflective clouds, possibly because it is simply too hot for clouds of water vapor or ammonia to exist. Instead, the entire world remains shrouded in an opaque, light-devouring blanket of exotic gases. The result is a gas giant that is almost invisible to the human eye, a black hole-like sphere that only reveals itself by blocking starlight. Adding to its eerie nature, the planet radiates heat back into space, glowing faintly like an ember. This glow, however, is not visible in ordinary light. It can only be detected through sensitive instruments that capture infrared radiation. Imagine standing near a gigantic, invisible furnace, one that you cannot see but whose searing presence you can feel. The planet's darkness is not just visual, but symbolic, a reminder that not all worlds glitter with reflected light. Some worlds, like this one, lurk in shadow, absorbing all that touches them and giving back only a deadly, suffocating heat. Its closeness to its star ensures that it is tidally locked, with one side permanently facing the star and enduring endless scorching, while the other remains locked in perpetual night. On the day side, the atmosphere is blasted with radiation, fueling the black, heat-trapping gases. On the night side, the lack of stellar radiation means the darkness is nearly absolute, broken only by the faint glow of residual heat bleeding through the atmosphere. If one were to approach this world, the experience would be disorienting. No visible horizon, no reflected light, only darkness punctuated by the dim glow of its furnace-like heat. For astronomers, This planet is a fascinating puzzle because it challenges conventional models of planetary albedo. Most gas giants reflect at least some percentage of light due to clouds and atmospheric scattering, but this world seems to reject all reflection. Theories suggest that its atmosphere may contain unknown compounds that absorb almost the entire spectrum of visible light, making it the darkest exoplanet ever measured. Studying this phenomenon helps scientists refine their models of atmospheric composition and learn more about how exoplanets evolve under extreme stellar conditions. From a human perspective, this planet is the embodiment of a cosmic nightmare. Imagine descending into a world where your surroundings are pitch black, your instruments show rising temperatures, and the very air around you is suffocating and hot enough to kill in seconds. Unlike planets with storms or violent winds, this one's terror is subtle but overwhelming. It is a silent, lightless void that consumes everything. A planet where darkness is not just the absence of light, but an active force of absorption. This world's existence demonstrates that not all planets will conform to expectations of brightness or reflectivity. It shows us that there are planets which exist in a form of optical invisibility, making them harder to detect and even harder to study. Its pitch-black body, drifting so close to its star, serves as a reminder that the universe holds secrets that defy both intuition and imagination. If space is already daunting for its emptiness, this planet doubles that dread by being a true black nightmare, a furnace of heat shrouded in eternal darkness. Coro T7b, the lava world. This planet is one of the most terrifying visions of what a solid rocky world can become under the right, or rather wrong, conditions. Discovered in 2009 about 489 light-years from Earth, it was one of the first confirmed rocky exoplanets outside our solar system. At first glance, the idea of a rocky planet might make it seem Earth-like, but any comparison ends the moment its conditions are revealed. Orbiting so close to its parent star that a year lasts less than 21 hours, it is scorched by unrelenting radiation and heat, transforming its surface into a molten wasteland. Instead of oceans of water, this planet has oceans of lava, and instead of mountains of stone, it has shifting continents of molten rock that melt and reform under the blistering temperatures. Surface temperatures on the star-facing side are estimated at well over 2,000 degrees Celsius, hot enough to melt not only rock but also metals like iron, nickel, and aluminum. The day side of this planet is a true inferno, with vast seas of lava stretching for thousands of kilometers, bubbling and churning as the surface rocks boil away into vapor. These vaporized minerals rise into the atmosphere, condense in cooler regions, and may fall back down like rocky rain, creating a cycle of stone evaporation and precipitation far beyond anything we can imagine on Earth. What water does for our clouds and rain, rock does here, shaping an environment where the weather itself is molten. Because the planet is tidally locked, one side is perpetually bathed in light, while the other side is cast into eternal darkness. The night side, while cooler than the molten day side, is still hostile, with temperatures plummeting far below freezing, possibly allowing solid rock to exist in sharp contrast to the endless seas of lava on the opposite hemisphere. This extreme temperature difference between the two sides may drive ferocious winds and bizarre atmospheric dynamics. Imagine a horizon where one side is ablaze with rivers of lava and glowing volcanic seas, while the other is a frozen wasteland of stone and perpetual night. The boundary between these regions would be one of the most violent geological frontiers in the universe. Its atmosphere is thin and unstable, likely composed of vaporized rock and minerals boiling off the surface. Instead of clouds of water or ammonia, the skies here could be filled with clouds of silicates, iron vapor, and other exotic compounds, creating storms of ash and rock particles. These clouds would eventually condense and fall back, feeding the lava oceans with minerals in a cycle of destruction and renewal. This constant evaporation and recondensation makes the planet's surface an ever-changing cauldron, a reminder that geology itself can become weather under the right conditions. Studying this planet offers scientists valuable insight into planetary evolution. It is believed to be a stripped-down remnant of a larger gas giant that lost its thick outer layers due to its close orbit around its star. What remains is the exposed rocky core, a skeleton of what once may have been a massive world. This theory makes it even more terrifying. What we see today is not just a hostile planet, but the burned-out corpse of a once grander world, forever scarred by its star's intense radiation and tidal forces. Over time, it may continue to erode, boiling away piece by piece, until nothing remains but scattered debris orbiting its star. From a human perspective, setting foot on this planet is impossible. A single moment of exposure would reduce any human or machine to molten slag. Lava oceans, superheated rock vapors, and volatile winds make it an environment where survival is not even a question. It is instantaneous destruction. The very air is made of stone vapor, and the surface is an ever-changing hellscape of boiling magma and unstable crusts. It is a world designed not for life but for obliteration, a raw display of nature's violent extremes. Despite its horror, this planet is scientifically invaluable. It provides a living laboratory for studying what happens to planets orbiting close to their stars and how rocky worlds evolve under such conditions. It pushes the boundaries of geology, turning it into atmospheric science, and forces astronomers to reconsider what Earth-like really means. Just because a planet is rocky does not mean it is hospitable. In fact, as this planet shows, rocky worlds can be some of the most terrifying in the universe. In the catalogue of deadly planets, this one earns its title as the lava world. Its molten oceans, vaporized atmosphere, and searing temperatures make it a place where even metals flow like water and solid rock becomes liquid under the merciless glare of its star. It is a reminder that Earth's relative stability is rare and precious, and that elsewhere in the universe, rocky planets can become far more frightening than any gas giant. Gliese 436b. The Ice Ball from Hell. At first mention, an ice planet might sound serene, cold, barren, perhaps lifeless, but not necessarily terrifying. Yet this planet rewrites every assumption, twisting the idea of ice into something alien and horrifying. Located about 33 light-years away, it orbits a red dwarf star in the constellation Leo. Despite being classified as a warm Neptune, what makes this world so disturbing is its contradictory nature. It is both infernally hot and frozen solid at the same time. On its surface, fire and ice are not opposites, they coexist. Temperatures here reach around 400 degrees Celsius, hotter than a kitchen oven at full blast, hot enough to melt lead and incinerate almost any earthly material. Yet in defiance of this blazing heat, the planet's surface and atmosphere are dominated by solid water ice. This is possible only because of the extreme gravitational pressure locking the water molecules into a crystalline form so dense and compressed that they cannot melt, no matter how high the temperature climbs. The result is a planet covered in what can only be described as burning ice, a substance that should not exist but does, sculpting a landscape of impossible contradictions. Imagine standing on such a world. Around you, the environment is glowing with heat, the air itself thick with suffocating vapor, yet the ground beneath your feet is solid ice. Not the kind of ice we know on Earth, cold, slippery, fragile, but dense, hot, and unyielding, a prison of frozen water that burns to the touch. it would feel less like standing on a frozen lake and more like walking across solidified fire. An alien paradox where the normal rules of physics seem shattered. The atmosphere of this planet only adds to its nightmarish qualities. It is composed mainly of hydrogen and helium, making it utterly unbreathable, while the heat ensures that storms of vaporized chemicals swirl through its skies. Because of the intense radiation from its star and its short orbital period of just over 2 days, this planet is constantly being stripped of its atmosphere. Streams of hydrogen trail behind it like a comet's tail, bleeding into space in a never-ending cycle of loss. This makes the planet seem less like a stable world and more like a burning frozen corpse, slowly unraveling before our eyes. The concept of hot ice here is one of the most fascinating yet terrifying aspects. On Earth, we understand ice as fragile, melting at the slightest warmth. But under immense pressure, water molecules can take on exotic structures known as high-pressure ices. These exotic states, Ice 7, Ice 10, and others, are theorized to exist inside giant planets like Neptune and Uranus, deep below the surface, where crushing pressures trap water in solid form. On this planet, however, those exotic ices are not hidden deep inside, but exist right at the surface, exposed under extreme conditions. This means the very ground is alien matter, burning cold and burning hot at the same time, unyielding to any tool or machine we know. What makes this place so chilling is the idea that even if you could somehow survive the temperatures and atmosphere, there would be no escape from its contradictions. Any water brought there would boil instantly, but the ice around you would never melt. Fire and frost would fuse into a singular, deadly reality. For any explorer, it would be like stepping into a nightmare physics lab, where the familiar rules of heat and cold have been rewritten. Scientists believe this planet may represent a transitional state, a glimpse into what happens as Neptune-like worlds evolve under the relentless assault of their stars. Over billions of years, its atmosphere may continue to erode until only a hot, icy core remains, a skeletal remnant of a once more massive world. In this sense, the planet is not only terrifying in the present, but also a warning of planetary death, a slow unspooling that leaves behind something unrecognizable and alien. The imagery of this planet is hard to shake. A frozen hellscape glowing with heat, ice that burns but does not melt, a comet-like trail bleeding into the void, and an atmosphere that suffocates and scorches at the same time. Unlike many terrifying planets that overwhelm with storms, fire, or crushing gravity, this one terrifies because it shouldn't exist at all. It is a contradiction made real, a place where the very laws of matter bend under pressure, reminding us that the universe is not required to obey our expectations. In the catalogue of the most terrifying planets in the universe, this one stands out for its sheer paradox. A world of fire that cannot melt its own ice, a graveyard of water locked in burning prisons of pressure, and a cosmic warning that not all contradictions cancel each other out. Some of them form entire worlds. Kepler 10b, Fire and Rock. Kepler 10b is a world that seems less like a planet and more like the exposed heart of a cosmic forge. Located about 560 light-years away in the constellation Draco, it was the first confirmed rocky exoplanet discovered by NASA's Kepler mission. At first, the excitement surrounding its discovery was tied to the fact that it was solid and Earth-sized, but any illusion of familiarity disappears the moment you learn what kind of Earth-like conditions this planet actually has. With surface temperatures soaring above 2,500 degrees Celsius, Kepler 10b is an unrelenting inferno, a planetary blast furnace where rock itself glows and the line between solid and liquid constantly blurs. Orbiting its star at just a fraction of the distance Mercury does from our Sun, Kepler 10b completes a year in less than a single Earth day. This means the planet is locked in perpetual punishment, blasted endlessly by the light and heat of its star. The surface is a landscape of molten plains and jagged peaks, where oceans of lava replace water, and air, if it can even be called that, is filled with vaporized rock and metal. Standing here would feel like stepping inside the core of a volcano, except stretched across an entire planet. The planet is tidally locked, which means one side always faces its star. That day side is the true hellscape, hot enough to melt almost every known element, boiling away anything unlucky enough to exist on its surface. Lava oceans stretch out in violent seas, their currents not of water, but of molten stone, churning with unimaginable energy. Even metals like iron would flow like rivers here, glowing orange and red under the planet's searing glare. The night side, eternally shrouded in darkness, is a stark contrast, but it too is far from safe. While significantly cooler, the night side is likely covered in frozen rock and possibly suffocated by volatile gases condensed from the extreme temperature difference. The boundary between the two hemispheres would be a region of unimaginable turbulence, where winds of vaporized minerals whip across the planet at staggering speeds. One of the most terrifying aspects of Kepler 10b is its density. This is not a lightweight world, but a planet nearly 5 times as massive as Earth, with a gravitational pull that would make every step feel crushing. The surface gravity ensures that anything landing here, human, robot, or probe, would not only be cooked instantly, but also pinned under its own weight, struggling to function in the face of both heat and pressure. Even advanced machines designed for extreme environments would likely melt, crack, and collapse within seconds. Its atmosphere is likely thin and unstable, made not of breathable gases, but of rock vapors boiled from its molten surface. These vapors might condense into mineral clouds, raining shards of solid material back down, creating a cycle of fiery evaporation and solidification. Imagine weather where instead of water droplets, you have showers of molten silicates or metallic particles cutting through the air like knives. The skies would not be blue, but likely a swirling haze of red, orange, and black, glowing faintly from the reflection of the molten surface below. From a scientific perspective, Kepler 10b is fascinating because it represents the fate of rocky planets orbiting too close to their stars. Some astronomers believe it may once have been larger, possibly a mini Neptune or super-Earth with a thick atmosphere. Over time, however, the relentless heat stripped away its gaseous layers, leaving behind a naked, rocky core exposed to its star's fury. In this sense, the planet is both a survivor and a victim, a stripped-down skeleton of a once greater world, punished forever by its proximity to its star. To imagine standing on Kepler 10b is to imagine standing inside a star's furnace. The ground would glow beneath your feet, the air would shimmer with waves of searing heat, and the horizon would boil with rivers of lava stretching endlessly into the distance. Any spacecraft attempting to approach would be destroyed long before reaching the surface, undone by radiation, gravity, and sheer thermal violence. For life, the planet is not just inhospitable, it is actively hostile, a world that exists to incinerate and crush in equal measure. Kepler 10b is a terrifying reminder of how deceptive appearances can be. On paper, it is Earth-sized, rocky, and solid, qualities that might once have suggested the possibility of habitability. But in practice, it is one of the most brutal environments in the galaxy, a planet-shaped crucible that devours anything exposed to it. Where Earth nurtures life, Kepler 10b annihilates it. It is not simply hot or rocky, it is the embodiment of fire and rock taken to cosmic extremes. 55 Cancri e, the diamond furnace. This planet is one of the most famous and unsettling exoplanets ever discovered, often referred to as the Diamond Planet. It orbits a sun-like star about 40 light-years away in the constellation Cancer, and is what astronomers call a super-Earth. Twice the size of our world and about 8 times as massive, it has all the markings of a solid, rocky planet. But any comparison to Earth ends the moment we look closer. With surface temperatures estimated at more than 2,400 degrees Celsius, it is not a glittering paradise of jewels, but a raging inferno where nothing we know could survive. What makes this planet so extraordinary is its composition. Astronomers believe it could be carbon-rich, with conditions that allow carbon to crystallize into vast quantities of diamond beneath its surface. Imagine a world where mountains could literally be made of diamond, stretching upward under skies filled with scorching heat and suffocating gases. While the idea sounds beautiful, the reality is far from it. Any spaceship or explorer hoping to reach the surface would be incinerated before ever touching the diamond crust. What we see as treasure on Earth becomes meaningless in a place that burns with relentless fury. Orbiting its star, Copernicus, at a blistering pace, this planet completes 1 year in less than 18 hours. That means its days are an endless cycle of punishment, locked so close to its star that tidal forces have likely stripped it of any atmosphere. If a thin one still exists, it would be unstable and composed of toxic vapors, hydrogen cyanide and carbon monoxide, instead of oxygen and nitrogen. Breathing here would not just be impossible, it would be fatal in an instant. The most terrifying aspect of this world is the contradiction it represents. Beneath its surface, unimaginable riches may exist, enough diamond to dwarf Earth's supply 1 billion times over. Yet, those riches are forever sealed within a furnace that would destroy anyone who tried to reach them. It is like a cosmic trap, a planet that entices with the promise of treasure, but kills with heat, radiation, and gravity. The intense gravitational pull, far stronger than Earth's, would make every step feel like carrying mountains on your back, even if the environment itself didn't destroy you first. Scientists studying this planet also suspect extreme volcanic activity. With such high internal pressures and tidal forces from its tight orbit, its surface may be covered in superheated lava flows, constantly reshaping its diamond-rich crust. Imagine diamond mountains erupting with molten carbon, rivers of liquid rock flowing across the land, and clouds of vaporized minerals blotting out the sky. This isn't just a diamond world, it's a diamond furnace, a glittering hell where the line between beauty and horror completely disappears. From space, the planet may glow faintly red, shimmering from the heat radiating off its surface. Its night side, cooler yet still deadly, might sparkle faintly from crystallized carbon. But for all its otherworldly allure, it is one of the least hospitable places in the universe. Any notion of mining it for diamonds or using it as a resource is pure fantasy. The tools we have today, or even in centuries to come, would be no match for its destructive environment. This planet is a haunting reminder that beauty in the cosmos often comes with unimaginable danger. A world filled with diamond, yet utterly unreachable. A jewel in the sky, but one that burns hotter than almost anything we can conceive. In its contradiction, it represents one of the most terrifying truths of the universe. Sometimes what seems like treasure is actually a trap, and what seems beautiful can be utterly lethal. Kelt 9b, the ultra-hot gas giant. There are planets in the universe that redefine the very limits of what a planet can be, and this one is the perfect example. Kelt 9b is so extreme that it challenges the definition of a planet itself. Located roughly 670 light-years away in the constellation Cygnus, it orbits a massive blue-white star that is more than twice as hot as our Sun. The sheer proximity of this giant to its blazing star makes it unlike anything else we've discovered, a planet that is hotter than some stars, with a dayside temperature exceeding 4,000 degrees Celsius. To put that into perspective, that's hotter than molten lava, hotter than the surface of many red dwarf stars, and nearly hot enough to melt tungsten, one of the most heat-resistant metals known on Earth. This world is a gas giant, somewhat like Jupiter, but that's where the similarities end. It is locked so close to its star that it completes an orbit in less than 2 days. The side facing its star is constantly bombarded with extreme ultraviolet and X-ray radiation, stripping away its atmosphere bit by bit, blowing its gases into space in shimmering trails of hydrogen and other elements. Kelt 9b is literally being cooked and peeled apart by its parent star's intensity, slowly evaporating into the void. In many ways, it resembles a comet rather than a planet, with a streaming tail of vaporized atmosphere trailing behind it for millions of kilometers. The heat on this planet is so unimaginable that molecules themselves cannot survive. On Earth, heat breaks apart fragile things like ice, plants, or skin. On Kelt 9b, the heat is so ferocious that it tears apart hydrogen gas molecules, forcing atoms to exist in isolation. Metals that we know as solids on Earth, like titanium and iron, float in the atmosphere as vapor, glowing faintly in the inferno. Its atmosphere is a toxic soup of atomic gases, constantly churned and blasted by its proximity to its star. To even speak of weather here is misleading. This is not weather, but a cosmic storm of atomic violence. The most terrifying thought about Kelt 9b is that it exists at the razor's edge between planet and star. Its temperature and atmospheric chemistry are closer to that of a stellar object than a typical gas giant. Some scientists even describe it as a failed star, a body massive enough to behave like a planet, but punished by its environment until it blurs into something else entirely. If Earth is a cradle for life and Jupiter is a storm king, then Kelt 9b is a planet-turned-weapon, its very existence a demonstration of how unforgiving the cosmos can be. If you could stand, or rather attempt to exist, within the atmosphere of this world, the experience would be beyond lethal. The air itself would be toxic and unstable, made of dissociated atoms rather than stable compounds. Radiation from the star would pass straight through flesh and bone, shredding DNA in an instant. Even spacecraft designed with the most heat-resistant materials would vaporize long before they could approach the surface, undone not only by the heat, but by the unrelenting blast of ultraviolet energy. It is an environment that mocks the concept of survival. The planet itself is a furnace designed to annihilate anything. Astronomers suspect that Kelt 9b cannot survive indefinitely. The radiation streaming from its star is stripping away its mass at an incredible rate, effectively boiling it alive in cosmic terms. Over millions of years, it could be reduced to nothing more than a scorched core, or it could be entirely destroyed, consumed by the star it orbits so closely. This fate makes the planet both terrifying and tragic. It is a world condemned to die by the very star that gave it form. Another unsettling detail is its distorted shape. The tidal forces exerted by the star's intense gravity stretch the planet, pulling it into an elongated, football-like form. Instead of being spherical like Earth or Jupiter, it is warped and misshapen, a planet physically deformed by the stress of its existence. Imagine a world pulled apart, stretched and squeezed, its very identity reshaped under the weight of its stellar torment. From afar, if you could somehow observe Kelt 9b with your own eyes, It would likely glow faintly, not from reflected starlight alone, but from the heat of its own atmosphere. A world that radiates like a coal pulled fresh from a fire, drifting around a blue-white star that burns with unimaginable brilliance. The contrast would be mesmerizing, yet horrific. You would be looking at a planet caught in a death spiral, a doomed giant suffering under cosmic conditions that seem almost cruel. The significance of this discovery goes beyond fear. Kelt 9b teaches us what planetary extremes can look like. It proves that planets can survive in environments once thought impossible, even if survival is temporary and destructive. It challenges our ideas of where the line between planets and stars truly lies. And it forces us to confront the reality that not all worlds are nurturing, or even neutral. Some are active engines of destruction, violent furnaces that embody terror in its purest form. Kelt 9b is not just terrifying because of its heat. It is terrifying because of what it represents, the sheer indifference of the universe. It shows us that stars can create planets only to slowly erase them, that even giants can be broken down atom by atom. It is the ultimate lesson in cosmic fragility. Where Earth is a sanctuary, this is a slaughterhouse. Where Earth is balance, this is chaos. Where Earth gives life, Kelt 9b gives only fire. Osiris, the evaporating world. Among the most unsettling planets ever found is a giant that is literally disappearing before our eyes. Officially known as HD 209458b, but often called Osiris, this planet lies about 150 light-years away in the constellation Pegasus. At first glance, it might seem like just another hot Jupiter, a gas giant orbiting dangerously close to its star. But what makes Osiris truly terrifying is its fate. It is being boiled alive, stripped of its atmosphere, and evaporating into the void, leaving behind a massive trail of gas that stretches for hundreds of thousands of kilometers. It is not just a planet, it is a planet in the process of dying. Orbiting its star at only 1/20th the distance between Earth and the Sun, Osiris completes a year in just 3.5 Earth days. The proximity exposes it to an unrelenting bombardment of heat and radiation. Temperatures soar above 1000 degrees Celsius, hot enough to blast hydrogen, helium, and other gases out of its atmosphere. The star's intense radiation excites these gases and propels them outward, creating a tail of material much like a comet's. From afar, it doesn't resemble a stable planet at all. It looks like a giant world unraveling, a celestial object coming undone piece by piece. The escape of its atmosphere is so dramatic that astronomers were able to detect it directly. The first time humanity ever observed such a phenomenon. When Osiris passes in front of its star, starlight filters through its evaporating gases, revealing streams of hydrogen and other elements bleeding into space. In some ways, this planet is less of a solid world and more of a flowing wound, constantly hemorrhaging its own existence into the cosmos. The scale of this evaporation is staggering. Every second, Osiris is losing thousands of tons of mass. Over time, this process could strip it down completely, leaving behind only a rocky or metallic core, a ghost of the giant it once was. This isn't just destruction, it's transformation, a horrifying cycle where the very identity of the planet is erased by its star. For Osiris, survival isn't measured in stability. It's measured in how long it can hold itself together before being consumed entirely. If you could somehow exist in the upper reaches of its atmosphere, you would be caught in a storm of unimaginable violence. The winds here are not breezes of air, but supersonic torrents of hydrogen blasting into space. Radiation would pierce everything, your skin, your bones, even your DNA, while the pressure and heat would crush and cook you in the same instant. the planet does not just repel life, it obliterates the very idea of it. Osiris is also tidally locked, with one side forever scorched by its star and the other side locked in endless darkness. The day side is a seething cauldron, its atmosphere superheated and boiling away, while the night side is a turbulent frontier where gases swirl in violent currents as they escape into space. The contrast between sides would be extreme, but neither offers any hope. Both are battlegrounds where the war between planet and star rages without pause. Perhaps the most chilling aspect of Osiris is its role as a cosmic warning. This is a planet that demonstrates the ultimate vulnerability of even the mightiest worlds. Jupiter in our own solar system seems untouchable, yet Osiris is a Jupiter-like giant being stripped apart atom by atom. Its very name, borrowed from the Egyptian god of death and rebirth, feels eerily fitting. Osiris is not just dying, it is being reborn in the worst possible way, reshaped into something smaller, denser, and unrecognizable, if it survives at all. From Earth, astronomers can trace the trails of its atmospheric escape stretching outward like a cosmic scar, a reminder that not all destruction is sudden. Sometimes, the universe erases things slowly, painfully, in plain sight. Osiris is a planet we can watch die in real time, its agony stretched over millions of years. The terrifying beauty of Osiris is that it looks like a comet, but is in fact a planet. It glows faintly in ultraviolet light, shimmering as its atmosphere peels away into nothingness. It is a haunting reminder that stars are not gentle givers of warmth. They are merciless destroyers that can strip entire planets of their essence. Gliese 581c, the potentially toxic Earth twin. There are few things more unnerving in astronomy than a planet that looks, at first glance, like a second Earth, only to reveal itself as a death trap. This is the case with Gliese 581c, a rocky exoplanet orbiting a red dwarf star just 20 light-years away. When it was discovered, it was hailed as one of the most promising candidates for habitability. Its size, mass, and distance from its star placed it right in the so-called habitable zone, the region where liquid water could, in theory, exist. Many called it Earth's twin, a world where life might thrive. But the deeper astronomers looked, the darker the picture became. Instead of a cradle for life, Gliese 581c may be a cosmic deception, a poisonous, suffocating inferno disguised as a paradise. One of the reasons this planet seems so appealing is its star. Red dwarfs are smaller and cooler than our Sun, which means their habitable zones are much closer. Gliese 581c orbits at just a fraction of the distance Earth does, completing a year in only 13 Earth days. At that distance, it sits right on the edge of its star's habitable zone. Too far, and it would be an ice-covered wasteland. Too close, and it would become a scorched greenhouse nightmare. Unfortunately, evidence suggests it leans toward the latter. The first major red flag is its likely atmosphere. Models indicate that Gliese 581c could suffer from a runaway greenhouse effect, similar to what happened on Venus in our own solar system, but potentially even worse. If its atmosphere is thick with carbon dioxide, the greenhouse effect would trap heat with devastating efficiency. Surface temperatures could soar high enough to boil oceans, if they ever existed, and leave the planet wrapped in dense, choking clouds. Breathing here would be impossible, not just because of the lack of oxygen, but because the air itself could be filled with suffocating gases like carbon dioxide, methane, or even hydrogen sulfide. What might look from afar like a shining blue marble could, in reality, be cloaked in a toxic shroud. Another terrifying feature is tidal locking. Like many close-orbiting exoplanets, Gliese 581c is thought to be locked with one side perpetually facing its star, while the other side is plunged into endless darkness. The day side would be a blazing furnace with scorching deserts and molten rock exposed to unrelenting starlight. The night side, on the other hand, would be frozen solid, bathed in eternal night. In between, along the thin twilight band known as the Terminator, conditions might be less extreme, but the winds would be catastrophic. Air masses from the hot side would rush toward the cold side in a desperate attempt to equalize, creating super hurricanes that tear across the surface with unimaginable force. Survival, even in this middle ground, would be nearly impossible. Radiation adds another layer of danger. Red dwarf stars are notorious for their stellar flares, sudden bursts of deadly radiation that can scorch nearby planets. Since Gliese 581c orbits so close to its star, it would be exposed to these flares constantly. Even if its atmosphere were thick enough to block some of the radiation, the sheer intensity of these stellar tantrums would make the surface an unpredictable and dangerous place. For any life form, survival here would be like trying to live inside a nuclear storm. Gliese 581c also challenges our assumptions about what a habitable planet even means. From a distance, it sits in the right place, with the right size and mass, seemingly ticking all the boxes. But habitability is far more complex than distance from a star. A thick atmosphere can turn a temperate world into a furnace. A weak magnetic field can leave it defenseless against radiation. A tidally locked orbit can create catastrophic extremes that make stable climates impossible. Gliese 581c is a reminder that the universe is not obligated to give us Earth 2.0 just because conditions appear favorable. Sometimes, what looks like paradise is actually a nightmare. Imagine for a moment that explorers landed here. The landscape might be rocky and alien, with jagged mountains rising under the dim, red light of its parent star. The star itself would hang huge in the sky, casting everything in eerie crimson hues. But the ground would be hot, the air dense and unbreathable. Every breath without a suit would be suffocating. Every moment outside would be a struggle against pressure, heat, and poison. The skies might be filled with thick, swirling clouds, trapping the heat below like a planetary oven. Lightning storms could crackle across the horizon, fueled by the turbulence between the hot and cold hemispheres. It would be a place of constant tension, constant violence, a world that destroys as much as it deceives. Hoth, the frozen wasteland. OGLE 2005. BL Chi, 390 pounds, often nicknamed Hoth due to its frigid resemblance to the ice planet from science fiction, is one of the most extreme examples of a frozen, inhospitable world in the galaxy. Located about 21,500 light-years away in the galactic bulge, this distant planet sits in almost complete isolation, orbiting a dim red dwarf star. Unlike planets scorched by relentless heat, Hoth is defined by an entirely different kind of terror: unyielding, suffocating cold. Temperatures on its surface plunge to a staggering -223 degrees Celsius, a realm so bitterly frozen that even the most heat-tolerant life forms from Earth would instantly perish. In essence, it is a place where heat itself seems to have abandoned the planet, leaving only frozen desolation behind. The surface of Hoth is a barren wasteland of ice and rock, with frozen plains stretching endlessly in every direction. Any water that exists is locked solid in high-pressure ice, and the weak light from its distant star barely touches the landscape, casting long, eerie shadows across jagged glaciers and icy cliffs. The planet's atmosphere, if it exists at all, is likely thin and composed mostly of inert gases, like nitrogen and carbon dioxide, providing neither warmth nor protection from the cosmic void. Unlike some icy worlds that harbor subsurface oceans warmed by tidal forces or radioactive decay, Hoth appears to be frozen throughout, a planet-wide freezer without any natural mechanism to thaw its icy grip. What makes Hoth particularly terrifying is its extreme isolation. It is far from its star, orbiting in a zone so cold that solar energy is negligible. Combined with its low mass, just slightly more than 5 times that of Earth, the planet is incapable of retaining a thick atmosphere, leaving the surface exposed to cosmic radiation and micrometeorite impacts. In such conditions, the planet is not just cold, it is an environment that actively destroys molecules, freezing chemical reactions, and halting the basic processes needed for life. Any probe or astronaut landing here would find survival utterly impossible without extensive artificial life support. The thought of Hoth evokes a kind of frozen silence that is almost alien. There are no storms like those on Neptune or Jupiter, no lava flows like on Kepler 10b, no boiling gases like on KEL T9b. Instead, there is a slow, creeping death of cold, where every exposed surface is a trap, every exposed molecule destined to freeze solid. Ice here is not just a surface, it is a weapon, as hard and unyielding as metal under extreme pressure, capable of shredding anything not reinforced against it. Even sunlight, feeble as it is, cannot provide warmth. Day and night blend into a perpetually cold twilight that dominates this planet. Tidal forces are minimal, yet gravity plays a subtle role in shaping the landscape. With a surface gravity slightly higher than Earth's, any movement across the ice is slow and cautious, made more dangerous by treacherous fissures and hidden crevasses in the frozen crust. The nights are darker than anything on Earth, with starlight reflecting off the ice like frozen diamonds, creating deceptive glimmers that could mislead an unprepared explorer. It is a place where perception itself can become a hazard, and even orientation becomes a struggle against the frozen monotony of the landscape. From a scientific perspective, Hoth is fascinating precisely because it represents the other extreme of planetary terror. While many of the universe's deadliest planets destroy with fire, radiation, or crushing pressure, Hoth annihilates life with absolute cold. The thermodynamics of its environment leave no room for conventional chemistry, making it a laboratory of frozen inactivity. It is a reminder that danger in the universe does not always roar or flare. It can whisper in the silence of ice, where nothing moves and nothing lives. The planet also serves as a warning about the fragile nature of habitability. Just a few 100 million kilometers closer to its star, Hoth might have been temperate enough to allow liquid water. A few kilometers thicker in atmosphere, and it could have trapped enough heat to make survival possible. The margin between frozen oblivion and life-sustaining warmth is so narrow that the difference between a thriving planet and Hoth's icy wasteland is almost negligible in cosmic terms. It is a stark illustration of how unforgiving the galaxy is to worlds that orbit too far from their suns. Hoth's horror is psychological as well as physical. It is not just a place that kills, it is a place that isolates, a planet whose emptiness presses against the mind as much as the ice presses against the body. Standing on its surface, one would confront the ultimate loneliness. Endless frozen plains, no movement beyond wind-swept snow and ice, no sound save the whisper of shifting glaciers. It is a planet where time slows, and the mind feels the creeping inevitability of the cold. Any notion of survival or warmth is an illusion, a cruel tease from the universe. In the catalogue of terrifying planets, Hoth stands out for its quiet brutality. Unlike worlds defined by fire, storms, or gravity, It terrifies because it is relentlessly still and cold, a frozen wasteland that obliterates life and hope alike. It reminds us that in the universe, danger does not always come in explosions or lava flows. Sometimes it comes as a slow, immutable freeze that can claim a planet in absolute silence. Hoth is a planet where the heat of life cannot survive, and where the cold rules with merciless patience. HD 80606b, the Extreme Orbit Giant. This planet is a study in extremes, a world that refuses to let anything remain stable or predictable. Orbiting its star in a highly eccentric path, it experiences swings in temperature so drastic that survival, if any life could exist, would be nearly impossible. During parts of its orbit, the planet is frozen, with temperatures plunging to hundreds of degrees below zero, while mere hours later, as it swings closer to its star, its surface is scorched to over 1,500 degrees Celsius. This dramatic shift in environmental conditions is unlike anything in our solar system, creating a landscape of violent contrasts that alternates between ice and fire in a relentless cycle. The physics behind this extreme behavior are fascinating but terrifying. Its orbit is elongated, resembling more of a stretched ellipse than a circle, which means the distance from its star varies drastically. At its farthest point, the planet drifts in a frigid void, barely warmed by the dim light of its star. Ice and frozen gases dominate the landscape, solidifying oceans and locking the atmosphere in a brittle, frozen shell. But as the planet hurtles closer to its star, it is abruptly thrown into a furnace-like environment. The atmosphere heats up rapidly, rock surfaces begin to vaporize, and any frozen compounds are instantly turned to gas or molten liquid. This oscillation between extremes happens with clockwork precision, but its consequences are catastrophic for anything trying to survive. The atmospheric dynamics of this planet are particularly nightmarish. The sudden heating as it approaches the star causes extreme expansion of gases, creating supersonic winds and violent storms. The planet's atmosphere is literally ripped apart and then compressed again as it moves between orbital extremes, producing shockwaves and violent turbulence across its entire globe. Winds of thousands of kilometers per hour likely sweep across the surface, carrying vaporized rock and frozen debris, making the skies an endless maelstrom of destruction. On the frigid side, gases freeze and settle in sharp crystalline structures, only to be ripped apart as the planet swings back toward the star. It is a world where the concept of weather is terrifyingly literal. Unimaginable forces batter the surface constantly, making even the idea of stability meaningless. Gravity adds another layer of danger. With a mass more than 4 times that of Jupiter, the planet exerts immense gravitational pull on itself and any nearby objects. This gravity, combined with the eccentric orbit, produces tidal forces so strong that the planet itself is likely stretched and compressed slightly with each orbit. Imagine a globe being squeezed and stretched like a cosmic stress ball, its crust and atmosphere flexing under the forces of orbital violence. For any spacecraft attempting to approach or land, these tidal forces would compound the already extreme challenges posed by heat and cold, turbulence, and atmospheric instability. The extreme temperature swings also make chemical reactions on this planet unpredictable and deadly. On the frigid side, elements remain solid and inert, frozen into stable configurations. But as the planet approaches perihelion, the sudden heat triggers rapid chemical transformations, vaporizing metals and creating clouds of toxic gases. It is a world where the surface itself is in constant chemical flux, as though the planet's crust and atmosphere are alive in a cycle of destruction and creation. Any hypothetical life would need to adapt not just to temperature extremes, but to a planet that reshapes itself chemically in hours. This planet challenges our understanding of planetary habitability and stability. On Earth, Ecosystems rely on the relative predictability of seasons and climate. Here, seasons are irrelevant because the extremes happen on timescales of hours, not years. The dayside's heat is so intense that it can melt rocks, while the nightside is so cold that even hydrogen compounds freeze solid. The boundary between hot and cold, day and night, is constantly shifting as the planet swings through its orbit, creating a world that is, in every sense, violently inhospitable. Astronomers also speculate that the extreme orbital behavior might have long-term consequences for the planet's evolution. The repeated thermal shocks could weaken the planetary crust, leading to volcanic eruptions or atmospheric instabilities that worsen with every orbit. It is a planet under constant stress, a world being reshaped by the interplay of gravity, heat, and orbital mechanics, where every revolution brings new terror. Observing this planet from afar offers a haunting spectacle. As it approaches its star, it brightens dramatically in infrared due to the intense heat, then fades again as it retreats into the frigid outer orbit. It is like watching a cosmic heartbeat of fire and ice, a giant in constant suffering under the forces of its star and its orbit. The scale of this transformation is almost unimaginable, a world capable of freezing entire oceans and boiling surface rock within the span of a single day. This planet embodies the universe's capacity for extremes. It reminds us that planets are not static objects. They are dynamic, often violent entities subject to forces far beyond human comprehension. While some worlds terrify with heat, others with cold, and yet others with gravity or storms, this planet's horror comes from its ability to combine all extremes into a single, relentless cycle. Here, stability is impossible, survival is inconceivable, and the laws of physics manifest in their most unforgiving form. Trappist 1F. The tidal horror. This planet is a chilling testament to the universe's ability to turn what might seem like a promising world into a living nightmare. Orbiting the ultra-cool dwarf star Trappist 1, this planet is one of several in a tightly packed system where worlds orbit close to their small, dim star. Its most defining feature is tidal locking, meaning one side is permanently turned toward the star, basking in relentless heat, while the other remains in perpetual darkness, frozen in extreme cold. The contrast between these hemispheres is staggering. The day side scorches at potentially hundreds of degrees Celsius, enough to melt surface minerals, while the night side plunges into frigid temperatures that would instantly freeze water and other volatile compounds. Any life would need to navigate, or survive, conditions that are simultaneously fiery and frozen, a planetary-scale version of hell. The tidal forces this planet experiences are perhaps its most terrifying characteristic. Orbiting so close to its star, gravity pulls unevenly across the planet, producing extreme tides that could theoretically tear apart the crust itself. Oceans, if they exist, may slosh violently toward the star-facing side, and then retreat toward the cold, dark hemisphere, creating tidal surges unlike anything seen on Earth. These tidal forces are not just surface phenomena. They extend deep into the planet's interior, generating internal stress, heat, and possibly constant tectonic upheaval. Continents could fracture under these pressures, with mountain ranges ripped apart and new rifts forming as the planet struggles under its star's grip. Any stable surface is fleeting, and any notion of peaceful geology becomes laughably impossible in the face of such violent dynamics. The atmosphere of this world, if it survives tidal stripping, is likely turbulent and chaotic. Winds would be driven by the extreme temperature difference between the scorching day side and the frozen night side, potentially reaching supersonic speeds. The terminator, the twilight zone between light and darkness, might be the only region with moderate temperatures. But even here, air currents would be relentless, creating storms capable of leveling geological features or whipping oceans into vapor. The pressure gradients between hemispheres could make the atmosphere itself a destructive force, tearing apart anything that dared to linger on the surface without protection. Radiation adds another layer of menace. Ultra-cool dwarf stars like Trappist 1 are known for violent flares, and orbiting close enough to be tidally locked exposes the planet to concentrated bursts of ultraviolet and X-ray radiation. The day side, facing the star permanently, is particularly vulnerable. Any thin atmosphere could be stripped away gradually by stellar winds, leaving the surface exposed to direct, punishing radiation. Combined with the already brutal tidal forces and extreme temperature gradients, this creates a planetary environment that is truly hostile on every conceivable front. Internal heat, however, might provide a macabre twist to the planet's surface conditions. Tidal heating generated by the constant gravitational tug-of-war could melt portions of the planet's mantle, creating intermittent volcanic activity. This might be the only source of dynamic geology that isn't immediately destructive. Yet even volcanic eruptions could add to the chaos, spewing molten rock into a planet already torn apart by tides and extreme winds. Lava flows on the day side could vaporize instantly, feeding turbulent clouds that then get transported by fierce winds to the frozen night side, only to condense or solidify in frigid darkness, a planetary scale cycle of fire and ice. The contrast between hemispheres also has terrifying implications for any theoretical hydrological cycles. Water, if present, could evaporate entirely on the day side, only to freeze solid on the night side, creating colossal ice flows that could fracture or submerge terrain. The Terminator may host transient rivers or seas, but their existence would be precarious, threatened by winds, tidal surges, and violent temperature swings. In essence, water itself, often a sign of life-friendly conditions, becomes an agent of destruction on this planet, moving with a violence that could reshape the landscape in hours. From afar, the visual spectacle of this world is haunting. One hemisphere glows faintly red under the star's constant glare. The other, a dark frozen expanse, reflecting only the dim light of distant stars. The planet's surface is in constant flux, scarred by tidal stress, volcanic eruptions, and ice movements. It embodies a balance the universe cannot maintain, a living paradox where extremes coexist in relentless opposition, creating a world that is both fascinating and utterly uninhabitable. This planet forces us to rethink what habitable zone truly means. While orbiting at the right distance for liquid water in theory, the reality is shaped by tidal locking, extreme heat gradients, and catastrophic geological forces. Its terrifying nature is subtle but absolute. It teaches that habitability is more than just distance from a star. Life requires stability, moderate climate, and protective conditions, all of which are obliterated here. Venus, the classic hellscape. Venus is perhaps the most infamous example of a planetary nightmare within our own solar system. Often called Earth's sister planet because of its similar size and mass, it is in reality anything but familiar or hospitable. Dense clouds of sulfuric acid hang thick in the atmosphere, creating a sky that burns with corrosive chemical clouds. Beneath these clouds, the surface is a brutal furnace, with temperatures exceeding 460 degrees Celsius, hot enough to melt lead and vaporize many metals. The combination of relentless heat, crushing atmospheric pressure, and corrosive air transforms Venus from a planet similar in size to Earth into a living hell. A stark reminder of how appearances can deceive when it comes to planetary habitability. The atmospheric pressure on Venus is staggering. At the surface, it is about 92 times that of Earth, equivalent to the pressure experienced nearly a kilometer beneath the ocean on Earth. This crushing force would instantly flatten any human-made structures or probe not specifically designed to endure it. Even spacecraft visiting the planet have only survived for hours before succumbing to the pressure, heat, and chemical corrosion. The thick atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid, traps heat with extreme efficiency, creating a runaway greenhouse effect that maintains the planet's searing surface temperature. This greenhouse effect is one of the most extreme in the known universe, making Venus a vivid cautionary tale for planetary science. The weather on Venus is just as hostile as its heat and pressure. The clouds of sulfuric acid swirl in a perpetual hurricane, with winds reaching speeds of over 360 kilometers per hour at higher altitudes. These winds move far faster than the planet's rotation, creating a phenomenon known as superrotation. On the surface, this may translate into fierce gusts and acid rain, slowly corroding the landscape and any object caught unprotected. Lightning storms, electrically charged clouds, and acid rain combine to make Venus not only uninhabitable, but actively destructive to any equipment or life attempting to exist there. Volcanic activity adds another layer of terror. Venus is home to thousands of volcanoes, many of them potentially active. Lava flows on the surface are both extensive and long-lasting, further enhancing the planet's reputation as a fiery, unrelenting world. These volcanoes are capable of releasing massive amounts of sulfur dioxide into the already toxic atmosphere, intensifying the acid clouds and heating the air further. The combined effects of volcanism, pressure, and greenhouse heating create a planet in which environmental conditions are consistently lethal. The surface of Venus is a strange alien landscape. Vast plains are punctuated by rugged mountains, cratered terrain, and lava flows that stretch for hundreds of kilometers. Rocks are baked by the relentless heat, and the sky above is a thick yellow-orange haze, obscuring the sun and casting an eerie glow over the desolate terrain. Day and night cycles are slow due to Venus's long rotation period. One day lasts 243 Earth days, but this provides little relief. The oppressive heat remains virtually constant, a continuous reminder of the planet's inhospitable nature. Venus also demonstrates the terrifying power of planetary feedback loops. The runaway greenhouse effect shows how a planet can spiral into extreme conditions once a certain threshold is reached. Carbon dioxide in the atmosphere traps heat, which prevents cooling, which allows more carbon dioxide to remain stable in the atmosphere, trapping even more heat. This self-reinforcing loop has rendered Venus uninhabitable, transforming a planet that might once have resembled Earth into a relentless furnace. It is a sobering example of how delicate planetary climates can be and how small differences can result in catastrophic outcomes. From a human perspective, Venus is a nightmare, not only physically, but also psychologically. The idea of stepping onto a world with searing heat, crushing pressure, acid clouds, and volcanic plains is almost unimaginable. Any unprotected traveler would be incinerated within seconds, crushed by the atmosphere, or corroded by the acidic air. Even robotic explorers are destroyed within hours. Venus exemplifies the extreme of what a terrestrial planet can become. A world that mirrors Earth's size, but utterly inverts its hospitable qualities, turning familiarity into terror. Scientific interest in Venus remains high precisely because it offers a glimpse into extreme planetary processes. Studying its atmosphere, surface, and geological activity provides clues about climate evolution, runaway greenhouse effects, and planetary habitability. Venus is a natural laboratory for understanding both the fragility of life-friendly conditions and the destructive forces that can dominate planetary systems. Its combination of heat, pressure, chemistry, and geological activity makes it a living demonstration of cosmic hostility, a classic hellscape where the forces of nature leave no room for comfort or survival. Jupiter, the Storm King. Jupiter is the undisputed monarch of storms in our solar system, a colossal gas giant whose sheer size and power inspire both awe and terror. It is more than 11 times the diameter of Earth and over 300 times its mass, making it a behemoth whose gravity dominates everything in its vicinity. Standing on any hypothetical solid surface, which doesn't exist as Jupiter is primarily a swirling mass of gas and liquid, would be impossible, and even approaching the planet with a spacecraft is fraught with peril. The gravity alone would crush an unprotected vessel, exerting forces so extreme that conventional engineering is rendered almost useless. Jupiter is a world that does not just challenge survival, it annihilates it through sheer physical dominance. But the true terror of Jupiter lies in its storms. The Great Red Spot, perhaps the most famous storm in the solar system, has raged for at least 400 years, possibly much longer. This hurricane-like system is so massive that it could engulf Earth twice over, spinning at hundreds of kilometers per hour. Its persistence is a reminder that on Jupiter, weather is not temporary. It is a force of relentless endurance, reshaping the atmosphere on scales and timeframes far beyond anything experienced on Earth. Surrounding the Great Red Spot are countless smaller storms and turbulent regions, creating an ever-changing mosaic of chaos. The planet's atmosphere is layered with intense jet streams that carve it into bands of high-speed winds, with adjacent bands often moving in opposite directions. These wind speeds can exceed 600 kilometers per hour, generating shear forces capable of tearing apart any object foolish enough to enter. Jupiter's magnetic field adds another layer of menace. It is the strongest of any planet in the solar system, generating radiation belts far more intense than Earth's Van Allen belts. These belts bathe the surrounding space in lethal levels of radiation, making it extraordinarily dangerous for spacecraft or potential explorers. Even robotic probes must be heavily shielded to survive long enough to collect data. For any human presence, the radiation alone is enough to be instantly fatal, making the planet's gaseous, storm-ridden atmosphere only one part of its deadly arsenal. The interior of Jupiter is equally extreme. Beneath the turbulent cloud tops lies a deep layer of liquid metallic hydrogen, a substance that behaves like a liquid metal under immense pressure. The pressure in Jupiter's interior is so extreme that it could crush conventional materials, and temperatures rise to thousands of degrees Celsius. These conditions produce magnetic fields, heat fluxes, and internal dynamics that feed back into the planet's violent weather systems, ensuring that Jupiter remains a constantly active, almost living, celestial entity. Its storms are not isolated events. They are the surface expression of deep, convective turbulence and a boiling, rotating interior that never rests. The planet's influence extends far beyond its own atmosphere. Jupiter's gravity sculpts the orbits of nearby moons and asteroids, shepherding swarms of objects in its vicinity and even protecting the inner solar system from some cometary impacts. Yet, this gravitational dominance comes at a cost. Stray objects caught too close are often shredded by tidal forces, torn apart as Jupiter exerts its immense pull. The planet acts both as a guardian and a destroyer, a celestial colossus whose presence is felt across millions of kilometers. Observing Jupiter from a distance is both mesmerizing and intimidating. Its striped bands of white, red, brown, and ochre swirl in endless patterns, the result of chemical interactions and turbulent winds. Storms erupt and dissipate, but some endure for centuries, carving persistent scars into the planet's gaseous exterior. The Great Red Spot alone is a spectacle of sustained fury, a roiling vortex larger than Earth itself, spinning endlessly in a turbulent dance that humbles any observer. Lightning storms within the clouds release enormous energy, with bolts hundreds of kilometers long and thunder that echoes across the dense, thick atmosphere. It is a world where natural forces operate on scales that defy comprehension, making human concepts of storms and weather seem insignificant. Jupiter is also a warning about the power of size and mass in determining planetary danger. While terrestrial planets rely on harsh surfaces, extreme temperatures, or toxic chemistry to threaten life, Jupiter's threat is physical dominance. Its gravity, magnetic field, and internal dynamics ensure that nothing fragile can survive in its realm. Even spacecraft, despite advanced engineering, are at constant risk from the combined forces of storms, radiation, and tidal stress. Jupiter doesn't merely resist exploration, it challenges it at every level, reminding us that the universe contains forces far beyond what we can manipulate or endure. Neptune, the wind terror. Neptune is a world of extremes, a planet where the fury of the cosmos manifests in relentless winds and freezing temperatures that would make Earth's harshest environments feel mild by comparison. As the eighth planet from the Sun, Neptune is one of the coldest and windiest planets in our solar system, a blue ice giant whose beauty belies the violence raging beneath its atmosphere. Its most notorious feature is the ferocious winds that can reach up to 2,100 kilometers per hour, the fastest recorded in the entire solar system. These winds, moving faster than the speed of sound on Earth, tear across Neptune's upper atmosphere, generating storms and turbulence so violent that any unprotected probe or hypothetical visitor would be obliterated instantly. Unlike storms on gas giants like Jupiter, which can persist in a single location for centuries, Neptune's storms are dynamic, shifting across the planet with unpredictable force, creating a chaotic and dangerous environment that is constantly in motion. The planet's temperature adds a chilling dimension to its hostility. Neptune is an ice giant, with atmospheric temperatures plunging to around minus 214 degrees Celsius near its cloud tops. This extreme cold compounds the danger of its violent winds, as even basic materials would become brittle, breaking under stress. Chemical reactions slow dramatically in such frigid conditions, but the planet's constant turbulence ensures that the frozen gases, primarily hydrogen, helium, and methane, are constantly mixed and displaced. Methane in the upper atmosphere gives Neptune its iconic deep blue color by absorbing red light. But this same methane participates in complex chemical reactions when subjected to the planet's immense pressures and high-speed winds, creating clouds and storms that can unleash catastrophic energy. Neptune's internal heat plays a critical role in maintaining its atmospheric violence. Despite being far from the Sun, Neptune emits roughly 2.6 times as much energy as it receives from solar radiation. This internal heat drives convection currents deep within the planet, forcing warmer gases upward and colder gases downward in a continuous cycle. The result is a turbulent, convective atmosphere, where storms can grow to enormous sizes and winds can accelerate to unprecedented speeds. The Great Dark Spot, a massive storm comparable in size to Earth, is a prime example of Neptune's atmospheric fury. Although smaller than Jupiter's Great Red Spot, this storm demonstrates the planet's capacity for extreme weather, spinning at incredible velocities and creating localized chaos that could obliterate anything in its path. The planet's structure contributes to its extreme conditions. Neptune is composed of a dense core surrounded by a mantle of water, ammonia, and methane ices, topped with a thick atmosphere of hydrogen, helium, and methane gases. The interplay between these layers produces turbulence at the boundaries, allowing enormous vortices and cyclones to form. These cyclones are not only immense in scale, thousands of kilometers across, but also incredibly energetic. Wind speeds and temperature differentials between atmospheric layers create shear forces that can tear apart clouds and stir the planet's atmosphere into violent, unpredictable patterns. For any object or probe entering this environment, survival would require withstanding both the sheer mechanical force of the winds and the corrosive effects of exotic chemicals carried aloft by these storms. Another frightening aspect of Neptune is its magnetosphere. The planet's magnetic field is tilted and offset from its rotational axis, creating irregular and dynamic interactions with the solar wind. This results in auroras of unimaginable scale at the poles, but also exposes the planet to high-energy particle bombardment. These particles, accelerated by Neptune's magnetosphere, can strike the atmosphere and surface with tremendous energy, contributing further to the harshness of the environment. Any spacecraft or probe attempting to study Neptune must contend not only with wind and cold, but also with intense radiation that can damage instruments or interfere with communications. Neptune's moons add another layer of complexity and danger. Triton, the largest moon, is a retrograde satellite, orbiting in the opposite direction of Neptune's rotation, and it is geologically active. Its icy surface contains geysers that spew nitrogen gas, creating plumes that rise hundreds of kilometers into space. Interactions between Triton and Neptune's gravitational field contribute to the dynamism of the system, and tidal forces from the planet could create additional internal stresses, further energizing Neptune's already violent atmosphere. While Triton itself may be a fascinating world, it is a reminder of how dangerous gravitational interplay can be in a system dominated by a massive ice giant. The combination of extreme winds, freezing temperatures, and high-energy radiation makes Neptune a uniquely terrifying environment. Its storms are not just violent, they are planetary-scale forces that dwarf anything experienced on Earth. The speeds of the winds alone are sufficient to strip paint off a spacecraft, tear through metals, and hurl atmospheric particles at deadly velocities. Coupled with near absolute zero temperatures, these winds create an environment where materials that might survive on Jupiter or Saturn fail catastrophically. Every hour on Neptune is a test of physics itself, where the planet demonstrates the sheer power of nature on a cosmic scale. Even visually, Neptune's serene blue hue is misleading. From afar, it appears calm, smooth, and almost tranquil, a jewel of the outer solar system. But this apparent serenity hides the ferocious activity beneath. Clouds are constantly rising and falling, storms are swirling unpredictably, and winds are tearing across the atmosphere with relentless power. Any visitor, probe, or satellite must be prepared for a world where conditions can shift violently without warning, where the combination of chemical activity, wind, temperature, and radiation ensures that Neptune remains one of the most hostile planets known to humanity. The lessons from Neptune are profound. While many terrifying planets rely on heat, pressure, or corrosive chemistry, Neptune demonstrates that cold, combined with wind and turbulence, is an equally deadly force. It also reminds us that appearances are deceptive. A calm blue orb can mask the most violent, unrelenting storms imaginable. For astronomers and planetary scientists, Neptune serves as both a laboratory and a warning, a reminder that extreme weather is not limited to Earth or gas giants like Jupiter, but can reach even greater levels on distant, frozen ice giants. Its combination of speed, cold, and chaos embodies the universe's capacity for subtle but overwhelming destruction, making it a true wind terror. Uranus, the sideways mystery. Uranus is a world that defies the conventions of planetary orientation and stability, earning its reputation as the sideways planet due to the extreme tilt of its rotational axis, roughly 98 degrees, essentially rolling along its orbit like a spinning barrel. This bizarre tilt is believed to be the result of a colossal collision early in its formation, an impact so massive that it knocked the planet onto its side. The consequences of this unusual orientation are profound, creating extreme seasonal variations that dwarf anything on Earth. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness, producing long periods of intense heating and equally prolonged freezes, which in turn influence atmospheric dynamics and storm activity in ways that are both unpredictable and deadly. Life, as we understand it, could not survive under such relentless and prolonged extremes. The atmosphere of Uranus adds another layer of danger. Composed predominantly of hydrogen and helium, with a significant portion of methane giving the planet its pale blue-green hue, the air is frigid and dense, with temperatures dropping to nearly -224 degrees Celsius. Methane not only colors the atmosphere, but also participates in fierce storm activity, forming clouds of frozen hydrocarbons that move violently across the planet. These methane storms can generate hurricane-force winds, potentially exceeding 900 kilometers per hour, with sudden shifts and turbulence that make the weather completely unpredictable. On Uranus, storms are not isolated phenomena. They can envelop entire hemispheres, propelled by the combination of axial tilt, internal heat, and atmospheric composition, making the planet an icy, storm-ridden nightmare. Internal dynamics contribute further to Uranus's hostility. Despite being an ice giant with a relatively small internal heat flux compared to Neptune, its interior remains active, with convection currents transporting heat and material from the core to the upper atmosphere. These currents interact with the extreme axial tilt to produce complex weather patterns, including massive cyclones and anticyclones. The atmosphere is layered with winds moving in opposite directions at different altitudes, creating shear forces capable of tearing apart clouds, ice formations, and any hypothetical structures within the atmosphere. The combination of supersonic winds, frigid temperatures, and chemical instability makes the environment utterly hostile to life or exploration. Gravity on Uranus, while less extreme than Jupiter or Saturn, still presents dangers. At 8.7 meters per second squared, it is only slightly weaker than Earth's, but coupled with the extreme atmospheric pressures found in deeper layers, gravity contributes to the crushing weight experienced below the upper cloud decks. Descending even a few hundred kilometers would expose an object to increasing pressure and temperature, making survival without specialized protection impossible. Combined with corrosive compounds and violent storms, these factors turn Uranus into a planet that is as physically punishing as it is meteorologically violent. The sideways tilt also wreaks havoc on Uranus's climate and circulation. With poles alternating between decades of light and darkness, the thermal balance of the atmosphere is continually disrupted. During the long polar summer, one hemisphere absorbs almost all solar energy, heating the upper atmosphere unevenly and triggering large-scale convection. During the polar winter, the other hemisphere plunges into darkness, freezing the atmosphere and allowing methane and other compounds to condense into ice clouds. This extreme oscillation produces seasonal storms that are unpredictable, combining freezing temperatures with violent wind systems, creating an environment where chaos is the norm rather than the exception. Uranus's magnetosphere adds another dimension to its danger. Its magnetic field is both tilted and offset from the planet's center, creating a highly irregular and dynamic magnetic environment. Charged particles trapped in this field are funneled toward the atmosphere at unexpected angles, producing auroras and energetic bombardments that further stress the planet's already extreme conditions. The magnetic irregularities mean that radiation levels can fluctuate dramatically across the planet, creating localized hazards that would be deadly for any spacecraft or hypothetical explorers. Observing Uranus from afar, its pale, calm blue appearance gives little hint of the violence it harbors. The apparent tranquility is deceptive. Beneath the serene exterior lies a planet in constant turmoil, with violent winds, colossal storms, and extreme seasonal shifts reshaping the atmosphere on timescales ranging from hours to decades. Its axial tilt ensures that the climate is never stable, with one hemisphere baking in light, while the other freezes, producing a level of environmental hostility unmatched anywhere else in the solar system. Uranus also highlights the interplay between planetary formation, impact history, and long-term climate effects. Its sideways rotation is likely the result of a massive collision, but the consequences extend far beyond orientation. This tilt governs wind patterns, storm formation, atmospheric circulation, and seasonal extremes, showing how a single catastrophic event can dictate the evolution of a planet's climate and surface conditions for billions of years. It is a chilling reminder that the universe can impose unpredictability on worlds in ways that defy human logic and comprehension. In summary, Uranus is terrifying not for fire, crushing pressure, or heat, but for its combination of icy extremes, violent storms, and bizarre orientation. It is a planet where seasons last for decades, where winds scream across frozen skies, and where methane storms create hazards that would obliterate any unprotected explorer. Its sideways tilt, extreme climate, and stormy atmosphere make it one of the most hostile and unpredictable planets in the known universe, a reminder that planetary terror comes in more than one form. Wasp 12b, the Star Eater. This planet is one of the most extreme examples of a world being actively destroyed by its own star. Orbiting its parent star at a distance of just 2 million kilometers, far closer than Mercury is to the Sun, this gas giant experiences tidal forces so intense that its very structure is being distorted. The gravitational pull stretches the planet into an elongated, football-like shape, a slow and violent deformation that is literally tearing it apart. Wasp 12b exists in a permanent state of structural agony, with layers of its atmosphere being siphoned off into space, forming an enormous comet-like tail of gas that stretches millions of kilometers away from the planet. The spectacle is both terrifying and fascinating, a cosmic drama of planetary destruction unfolding in real time. Temperatures on this planet are extraordinary, exceeding 2,500 degrees Celsius, hot enough to vaporize many metals and compounds in its atmosphere. The extreme heat, combined with the tidal stretching, creates a dynamic environment where the outer layers of gas are stripped and accelerated into space, forming a continuous trail of material. This process is not slow. The planet is losing mass at an alarming rate, and over astronomical timescales, it may lose a significant fraction of its original mass. This makes WASP 12b a rare laboratory for understanding the limits of planetary endurance under stellar assault and the ultimate fate of gas giants in extreme proximity to their stars. The composition of the atmosphere adds another layer of danger and strangeness. Observations suggest the presence of hydrogen and helium typical of gas giants. But at these extreme temperatures, molecules are ripped apart into atoms and even ionized into plasma in certain regions. Stellar radiation bombards the atmosphere relentlessly, causing intense heating and further accelerating the escape of atmospheric gases. The upper layers of the planet are essentially in constant motion, streaming outward into space, forming a tail that rivals the size of some stars' own coronae. This tail is not just a passive feature, it is a dynamic, ever-changing structure shaped by the interplay of stellar radiation, planetary gravity, and tidal forces. Wasp 12b's proximity to its star also creates dramatic tidal locking, ensuring that one hemisphere faces the star perpetually while the other remains in darkness. The day side is an inferno, receiving a continuous barrage of radiation and heat that drives supersonic winds flowing toward the night side. These winds can reach thousands of kilometers per hour, moving superheated gas in massive, turbulent flows that further destabilize the atmosphere. The contrast between the day and night hemispheres exacerbates the planet's internal stresses, feeding into its ongoing deformation and mass loss. Observationally, WASP-12b presents a vivid picture of extreme physics. Astronomers studying the planet with space telescopes have detected its extended gas tail, measured its extreme temperatures, and observed the unique signature of its distorted shape. These data provide a glimpse into a stage of planetary evolution rarely seen, a world being actively cannibalized by its star. The insights gained from WASP-12b challenge our understanding of planetary stability, tidal interactions, and atmospheric escape, revealing a level of cosmic violence that seems almost theatrical in its scale. The fate of WASP-12b is inevitable. Given its current rate of mass loss, it may eventually be stripped down to a dense core, or even entirely vaporized over millions of years. Unlike typical planetary lifetimes, which span billions of years in relative stability, WASP-12b's existence is measured by the slow but relentless hand of destruction. It is a reminder that the universe is not just a place of formation and creation, but also of erosion and annihilation, where even planets are not immune to the forces of entropy and stellar violence. For any potential observer, imagining the conditions on this planet is enough to evoke fear. The unrelenting heat, violent winds, distorted gravity, and the ongoing stripping of its atmosphere create an environment where nothing could survive, even theoretically. WASP-12b represents one of the most hostile, violent, and nightmarish planetary environments known. It is a living example of a world at the edge of destruction, where the forces of gravity, radiation, and tidal stress converge to produce a spectacle of cosmic violence. This is not merely a hellish world in theory, it is an actively dying planet, offering a window into the destructive potential of stars on planets that venture too close. The most terrifying planet in the universe, TOI 849b. This planet represents a level of cosmic hostility that is almost incomprehensible. Unlike typical planets, which have gaseous envelopes or relatively benign rocky surfaces, this planet is essentially a bare planetary core, stripped of any outer layers during a cataclysmic event in its history. At twice the size of Neptune, and with a density comparable to iron, its gravity is extraordinary, exerting a crushing force that would obliterate any object or spacecraft attempting to approach its surface. The sheer mass concentrated in a relatively compact volume transforms it from a planet into a near-lethal gravitational trap. The experience of approaching this world would be one of escalating terror. Tidal forces would stretch and compress any material long before it even reached the core, and atmospheric or surface conditions would be utterly irrelevant compared to the overwhelming gravity. This planet is believed to be the remnant of a once massive gas giant that lost its outer layers, likely through intense stellar radiation or a violent encounter with another celestial body. What remains is a relic of catastrophic destruction, a core exposed and unshielded, floating in its star system as a testament to cosmic violence. Its surface, if it can even be called that, is likely a solid metallic crust over an extremely dense interior, where pressures reach levels impossible to replicate on Earth. Any probe attempting to penetrate the surface would be crushed under the weight of layers upon layers of dense iron-like material, and conventional instruments would fail under the intense gravitational compression. The environment here is not merely inhospitable, it is actively lethal in every measurable way. Temperature conditions on this planet are also extreme, though in a different sense than the searing heat of lava worlds or ultra-hot gas giants. Lacking a significant atmosphere, it is exposed directly to its star, if close enough, with surface temperatures likely varying widely depending on stellar distance and rotation. Without an atmosphere to distribute heat, the day side could experience intense radiation, while the night side plunges into freezing cold, creating a combination of thermal extremes that would further challenge survival. Additionally, any residual atmospheric gases from its stripped past could be highly reactive, and high-energy particles from the star would bombard the planet unimpeded, adding yet another layer of danger. The gravitational effects of this planet are perhaps its most terrifying feature. Being so dense, it produces tidal forces strong enough to warp objects at considerable distances. Even approaching the planet in orbit would require calculations beyond conventional spacecraft engineering. Tidal stresses could elongate structures, distort instruments, and create stresses capable of tearing apart metal and composites alike. The crushing gravity ensures that nothing loosely bound could survive long on or near the surface. In essence, the planet's gravity acts as a deadly sculptor, reshaping and destroying anything in its reach while maintaining its own overwhelming stability. In terms of planetary dynamics, this planet is unique. It lacks the gaseous envelope that softens the gravitational pull of typical gas giants, and it is far more compact than terrestrial planets of comparable size. Its density suggests a composition rich in iron and heavy elements, which implies a gravitational pull so strong that it could retain residual heat for billions of years. The combination of extreme density, small radius relative to mass, and potential rotational forces could generate intense surface gravity variations, leading to geophysical phenomena unlike anything observed in our solar system. Any tectonic or geological activity would be driven primarily by residual heat, stress from past collisions, and gravitational compression, producing a planet that is active in an unusual, terrifying way. This planet also challenges our understanding of planetary formation and evolution. Typically, planets form with either a substantial gaseous envelope or as smaller rocky bodies. But this planet is a stark reminder of what remains when those processes are violently interrupted. Its current state suggests it survived dramatic stripping, likely due to close encounters with its star or catastrophic collisions with other massive objects. It is essentially a skeleton of a giant, providing scientists with a rare glimpse into what happens when planetary evolution is interrupted by extreme cosmic events. Studying this planet allows astronomers to understand the ultimate limits of planetary survival, the thresholds of gravity and density, and the catastrophic consequences of tidal stripping and stellar interaction. The visual and conceptual image of this planet is haunting. Unlike the vibrant gas giants with swirling storms or the icy blue of distant Neptune, this planet would appear dark, dense, and imposing. Its surface, metallic and unyielding, might glint faintly under starlight, but there would be no atmosphere to scatter light or clouds to obscure the harsh reality. The planet is a solid, unforgiving object in space, radiating nothing but the silent menace of gravity itself. Its sheer presence would dominate any nearby system, warping orbits and influencing other celestial bodies with its immense mass. The starkness of its appearance only adds to its reputation as the most terrifying planet in the universe. In terms of existential threat, this planet is unparalleled. While other terrifying planets feature extreme heat, crushing pressure, or violent storms, this planet's danger lies in the fundamental force of gravity itself. There is no refuge here, no breathable atmosphere, no temperate zone, no survivable surface. Every molecule, every probe, every fragment of material is subjected to forces that can crush, distort, and annihilate. Its existence is a reminder that planetary danger is not only about surface conditions, but about the underlying physical properties of the planet itself: density, mass, gravity, which cannot be shielded against or mitigated easily. Beyond its destructive potential, this planet represents the ultimate story of survival and endurance. Despite the violent events that stripped it of its outer layers, it remains intact, defying the chaos that could have completely destroyed it. Its current state is a testament to the resilience of planetary cores, but also a chilling example of cosmic punishment. What remains is almost exclusively lethal. The universe has created something here that is fundamentally incomprehensible in terms of human experience. A world where survival is impossible, where the fundamental forces of nature dominate completely, and where the very act of existing is a warning. This planet forces us to confront the limits of imagination. Even the most hostile gas giants, ultra-hot Jupiters, or frozen ice worlds pale in comparison. Here, there is no atmosphere to buffer the extremes, no clouds to moderate temperature, and no storms to warn of danger before it strikes. Every aspect of this world, its gravity, density, potential heat, and history of destruction, converges to produce an environment that is, in every sense, a planetary executioner. It is a cosmic reminder that the universe is capable of producing conditions so extreme, so utterly lethal, that human comprehension falters. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.